Let's see today's problem of the day on LeetCode. So the question is, you are given an array nums, and what you have to do is you have to calculate XOR total of an array and do sum of it and return it. So what is XOR total? So XOR total is like you have to generate all the subsets of the nums, okay, and then you have to XOR them, and then the result which will come at the end, you have to sum it of all subsets. So for this example 5 and 6, what are the subsets of this array? One subset is 5 1 6, 5 1 5 6 1 6 and 5 1 6. So now what we have to do, we have to XOR of all of these subsets individually. So XOR of 5 is 5, XOR of 1 is 1, XOR of 6 is 6, and then XOR of 5 1 is 4, 5 6 is 3, and 1 6 is 7, and 5 1 6 is 2. Now what we have to do, we have to sum all these values 2 7 3 4 6 1 5, which will at the end be 28, and we have to return it. So brute force solution for it will be, we can generate all the subsets of this array, and then do the XOR of them individually and return the answer. But we can solve this in big of n also, because there is a pattern. If we observe the XOR total of each subset, let's write it. So the XOR total of first subset is 5, which will, if we observe the binary representation of it, so the first subset will be 101, second will be uh, 0 0 0, it is 1, so it will be 0 0 1. Third will be 6, which is 110. Fourth is 4, so which is how much? Yeah, 100. Yes. Fifth is 3, so which is 0 1 1, and sixth is 7, which is 111. So if we observe this, okay, we generated all the subsets and we did the XOR total individually, and then if we observe the binary representation of it, so we can see that each bit is coming 4 times. In this case, see, the 0th bit is coming 4 times, means set bit 1 2 3 and 4, and likewise the first bit is also coming 4 times. uh, have we missed one thing? 5 1 uh, 6, this is 6, yes, then 4, then 3 0 1 1 7, and yes, at last 2, we have missed the last one, so it is 0 1 0. Yeah, so this first bit is also coming 4 times, you can see here, and the second bit, which is the rightmost bit, is also coming 4 times. Okay, so so this is the pattern. So like every bit will come 2 to the power n minus 1 times. Okay, so here what is n? N is the length of the array, so n, for this case the length of array is 3, so 3 minus 1 is 2, and 2 to power 2 is 4, so that's why every bit is coming 4 times. So what we can do is, we can just calculate that how much set bits are possible. So how can we do that? So we'll just take OR of 5 1 and 6. Okay, 5 1 and 6, OR of 5 1, if we write 5, this is 5, this is 1, and this is 6. So if we take the OR of all of them, which it will be 1 1 1, because obviously if one also bit is even if one bit is set, then the final bit will be set. So in all these all the bits are set in all the positions, so 1 1 will be the answer for if we do the OR of the nums array. So that means in the final thing, every the bit at every position will come 2 to the power n minus 1 times. So then we will just multiply 2 to the power n minus 1 is 4, so every bit will come 4 times, so it will be um, if we calculate the sum, so it will be like yes, the second position bit, the value of second position bit is how much? It is 4. So 4 into 4, this will be 16. Then the value of first position bit is 2, so 2 into 4, it will be how much? 8. And the value of zeroth position bit is 1, so 1 into 4, it will be 4. So at last the final answer will be how much? It will be 16 plus 4 plus 8, which is how much? 28. Okay, yeah, so this can be done in big O of n. So let's write a code for it. I will just take an OR variable, which will be used to do OR of every element in the array. Okay, and OR is equal to OR nums of I, and yes, now I will calculate the number of not actually number of the set bits. I will calculate the 2 to the power n minus 1 thing. So let's put it like this. Use an inbuilt function math dot power 2 to the power nums dot length minus 1, and until the bit is not the OR is not 0, we will like traverse the all the bits of the variable OR, which is the OR of all the elements in the nums. We'll also take an variable I, which will tell us the which will help us to tell the value of the position of the bit. Yes, now if the current bit is set, for that we can just do if OR and 1, this is equal to 1. What we'll do, we'll first of all we have to take an answer variable, int answer is equal to 0. We'll just add this in our answer. What we'll add, z multiplied by, which is 2 to the power n minus 1, multiplied by the value of the current bit, that is yes, it will be how much? 2 to the power I. Let's convert this into int. Yes, and at last we'll do I plus plus, and OR is equal to OR right shift 1, and we will return the answer. Yeah, let's try to run this. Yes, it's getting accepted for the sample test cases, and is successfully submitted. Okay, thank you for watching.